All right, lesson 1-7, more information about triangles and properties and characteristics. Okay, so you don't have to copy this stuff down. We already have these in our notes. So we know that the three interior angles of any triangle add up to 180 degrees. We have our relationship that an exterior angle is equal to the sum of the two non-remote interior. We've looked at classifying triangles, and we know when we classify triangles, we have to classify using their side lengths and their angle measures. And then the last thing we studied was the relationship between sides and angles. So we know that an angle corresponds to its opposite side. So angle A would be opposite side length A, angle B, opposite side length B, and then angle C, opposite side length C. Okay, so the first special triangle we'll study today is an isosceles triangle. So take a minute and copy the picture down for me. So an isosceles triangle. At least two sides of the triangle are congruent. Okay, the angles opposite the congruent sides.
I'm on my own.
They're called your base angles.
Yes. Sorry.
And if we use the relationship between angles and their sides, if my base angles are opposite the congruent sides, then we know that the base angles are congruent as well. Okay, and then lastly, this is from the picture, but the non-base angle, that's known as our vertex. Okay, so let's use this information. Take a minute, copy these three triangles down, and we're going to find the missing information in each triangle. Okay, so when I look at triangle SRT, I notice that angle R is congruent to angle T, so that tells me that segment SR would be congruent to segment ST. Okay, so that tells me that it's an isosceles triangle. And if I'm looking for the measure of angle S, well then I can use my triangle sum theorem. So the measure of angle S plus the two base angles, I know that that's going to be equal to 180 degrees. Okay, so this gives me 128. When I subtract 128 from both sides, the measure of angle S will be equal to 52 degrees. And because of its placement in the triangle, this is my vertex angle. Okay, my next triangle, I need to give you this bit of information. So we have to be told triangle ABC is isosceles. And I'll tell you that the vertex is angle B. So if angle B is the vertex, if I tell you it's isosceles, I know those two sides are congruent, and therefore angle A and angle C would have to be my vertex angle, or excuse me, my base angles. So I know the measure of angle A plus the measure of angle C plus 120 degrees, that has to equal 180. That's my triangle sum. Furthermore, I know these are the same value. They represent the base angles. They're opposite the congruent sides. Subtracting 120 from both sides, I get 60 degrees. So each angle measure would equal 30 degrees. Okay, so the measure of angle A is 30 degrees, and the measure of angle C would be 30 degrees. Okay, and lastly, the third triangle, All right, it's not, we can't name it. The vertices aren't named at all, but I do know that these two tick marks tell me these side lengths are congruent. So if one leg has a measure of 9, I know it forces the other leg to have a measure of 9 as well. Okay, the second special type of triangle, and we've looked at these with the classifying worksheet, an equilateral triangle. So an equilateral triangle, all my sides are congruent, and therefore all the lengths are equal. All my angles are congruent. Okay, so if all the angles are congruent, that means these three angle measures are all the same value. So I know that the measure of angle A plus the measure of angle B plus the measure of angle C is going to be 180 degrees. That's true for any type of triangle. Furthermore, each of these angles are congruent, so their measures are the same. So if I call them X, dividing this equation by 3, each angle measure of an equilateral triangle is 60 degrees. Okay, the sides never add up to one specific value, but I do know that all the side lengths are congruent. Okay, let's use that information. Find the length of each side in the given triangle. So we don't ever have to find the measure of the angles in an equilateral because I know they're always going to be 60. Okay, the tick marks tell me that the three sides are congruent. So if I know one length is 15 centimeters, the other two lengths would be 15 centimeters as well. Okay, lastly, I know triangle ABC is equilateral. So with the triangle being equilateral, then any two sides we can set equal to each other to solve for x. So we can say 4x plus 8 equals 6x. I can say 4x plus 8 equals 3x plus 12. Or I can say that 6x equals 3x plus 12. And we'll show that no matter what equation you set up, we'll get the same value of x. So subtracting 4x from both sides here, I get 8 is equal to 2x. Divide both sides by 2, I get x is equal to 4. Okay, I'm going to subtract 3x from both sides first, and I get x plus 8 is equal to 12. Subtracting 8 from both sides, I get x is equal to 4. And then my last equation, if I subtract 3x from both sides, I get 3x equals 12, and x is equal to 4. So it doesn't matter which equation you set up, because all the sides are equal. That's what makes it an equilateral triangle. Okay, so now to answer the question, find the length of each side. So now that I have my value of x, I have to go plug it back in. So 6 times 4 would give me 24. Okay, let's verify that we get the same answer. Substituting 4 for x, 3 times 4 is 12, plus 12. I get the second side length to be 24. And then lastly, substituting again, 4 times 4 is 16. 16 plus 8 gives me the third side length of 24. Okay, lastly, I'm going to have you complete this problem for homework. Find x and y in the triangle below. So looking at the markings, triangle ABC is isosceles. So in order to solve this, what do you need to recall? That the legs are congruent, and I know that the base angles are congruent as well. So from each of those statements, you need an equation. You're going to have one equation to find x, and you'll have a separate equation to find y.